This is a GATE problem from Instrumentation Engineering paper on the Sensors and Industrial Instrumentation module. So the problem concerns that of the thermistor, which is a thermally sensitive resistor, and the problem is stated as follows. A thermistor has a resistance of 1 kilo ohm at temperature 298 Kelvin and 465 ohms at temperature 316 Kelvin. The temperature sensitivity in Kelvin inverse, that is 1 by R dr dt, where R is the resistance at the temperature T in Kelvin of this thermistor at 316 Kelvin is dash. So basically they want to find out the sensitivity of the thermistor at exactly 316 Kelvin, and we know from our understanding of thermistor that the sensitivity is a dynamic one. That means for point to point in the temperature scale, the sensitivity will vary. So the problem is pretty simple. All we have to do is to remember the basic concept of the resistance versus temperature profile of the thermistor, and it is governed by this particular equation. So the equation is RT is equal to R naught into e to the power beta times 1 by T minus 1 by T naught, where RT is the resistance of the thermistor at T Kelvin, R naught is the resistance of the thermistor at T naught Kelvin, and the term beta, this is dependent on the material of the thermistor. So looking at the question, our temperatures of interest are 298 Kelvin, where the resistance is 1 kilo ohm, and 316 Kelvin, where the resistance is 465 ohms. So if we plug in those values, so we are looking at the resistance at 316 Kelvin, and this is equal to R naught. So R naught here will be the resistance at 298 Kelvin times e to the power beta multiplied by 1 by T is equal to 316 negative of T naught is equal to 298. And then we can easily plug in the values of R316 as 465 ohms and R298 as 1 kilo ohm. So 1 kilo ohm is equal to 1000 ohms. And from here we use the simple rules of algebra along with logarithm. So we can have 465 by 1000 and then take log of base e to both sides, and we can frame the expression for beta like so. Upon solving, we obtain beta as 4002.3. So normally you will find that in the textbooks they mention the value of beta to be somewhere about 4000 or maybe 3900 and so on. So this fits our bill, and once we obtain the value of beta, we can again refer back to the theory, and we know that the sensitivity of the thermistor is given by negative of beta by T square. So you can take the derivative of this RT with respect to T, and you can come up with this equation. Of course, dividing by 1 by R, and therefore the sensitivity value, which is given by negative of beta by T square, we have found out the value of beta as 4002.3, and we are looking at the temperature of interest, which is 316 Kelvin. So negative of 4002.3 by 316 square is equal to negative of 0.04. So the sensitivity is negative, and this simply implies that this is a NTC type thermistor. The other way to look at the fact that this being an NTC type thermistor is the fact that for a lower temperature 298 Kelvin, the resistance is 1000 ohms, whereas at a higher temperature 316 Kelvin, the resistance has dropped down to 465 ohms. So this is a pretty simple problem which tested our understanding and our memory regarding this equation RT is equal to R naught e to the beta into 1 by T minus 1 by T naught, and then the sensitivity equation of a thermistor. This is the dynamic sensitivity of the thermistor, which is equal to negative of beta by T square. Simple problem, 2 marks. Hopefully you can easily solve this sort of questions.